Hi, I am Hossein Hariri, and this is a video from Zal Yafte Academy. www.zalacademies.org. Check the description of this video before starting to watch it. If you are using a computer, the description is at the bottom. Click Show More to see more of the description. If you are using a tablet or a mobile, click on the little arrow at the bottom right to view the description at the bottom or on the right of the video. The description tells you where to find the statement of a problem and the meaning of a problem ID. If you click on the link for a problem given in the description, the video will fast forward to play the solution of that problem. When a problem takes more than one slide, you can see a phrase in the parentheses in front of the problem ID that says, "See the next slide for more." The last slide for such a problem has the word "continued" in short form after the problem ID. If the solution of a problem needs explanation, it has been added before the solution is presented. Otherwise, the slides for a problem will be played after a start sound. The transition of each slide normally takes 12 seconds. This video is on the problems in topic 1. There are 3 problem sets in this topic. Problem set 1 is on units and significant figures. This problem involves significant figures. Note that the down arrow indicates the last significant digit of a number. Problem set 2 is on interpolation and equations. The instructions for interpolation are available in the lecture note on the website before the problems. In this problem, a nonlinear equation is solved. The unknown is the friction factor F. We may solve a nonlinear equation using Microsoft Excel. To do this, you need to set up the problem as appropriate. The items on the sides of the equation are defined as left-hand side LHS and right-hand side RHS. We formulate LHS and RHS as shown. Since friction factor F, which is the unknown in the problem, is also an item in LHS and RHS, we need to assume an initial value for it. As you see, for the friction factor F, in the blue cell, a value of 0.01 has been assumed. With this, and using all other parameters which have known values, we get LHS to be 10 and RHS to be 7.04. Obviously, if the value of 0.01 for F were the right answer, it would make LHS and RHS equal to each other. In another word, f of f, which is defined as LHS minus RHS, would be 0. So Excel should change 0.01 for us in order to make f of f 0. In this slide, we are using goal-seek in Excel to carry out this task. Solver in Excel may also be used to do the same job. Problem set 3 in topic 1 is on dimensional homogeneity, which has been described in the lecture note. This problem involves unit conversion. Note that the down arrow indicates the last significant digit of a number. In this slide, we want to write an equation with different units. The equation in the problem involves variables q, l, h0, and g, all with units in American engineering system, that is foot and second. We would like to write the equation in a new form where the units of the new variables are in meter and second. In the lecture note, we learned that we need to denote the new variables first. If q is in foot cube per second, the new variable q prime is defined in meter cube per second. Then we need to write an equation where q is on the left-hand side and q prime is on the right-hand side, and make the equation dimensionally consistent by multiplying the appropriate conversion factors as shown. Finally, substitute for the old variables in terms of the new variables and simplify the final answer. We have learned from the lecture note that the argument of log, that is pressure P here, must be dimensionless. However, here P is in millimeter of mercury, which violates that rule. To go around this, we can say that the argument of log is 1P, which is practically the same as P. However, this will give us the opportunity to assume the units of 1 as 1 over millimeter of mercury, and when it is multiplied by P, the term 1P becomes dimensionless.